So let's talk a little bit about this hierarchy of different collection classes in Java library and their general purpose. The most basic type of collection is ArrayList. Now, ArrayList name by itself sounds a little strange. List is like a sequence of things, and array is also like a sequence of things. So then we have this combination ArrayList. And the reason behind this name chosen in Java library is that ArrayList organization internally is such that this reference that we create right here, okay, so the object gets created, and the object is created, and this is our array list of integers, because this, remember, this empty diamond box presumes that we're using integer to create this array list. So this is our array list object right here. So it's designed to contain elements, just a sequence of elements. But internally, array list, and that's the array part of its name, is using Java arrays. Okay, so internally it's using Java arrays to store the elements. So these integer objects that we're going to populate inside this array list will be wrapping individual integers, and when we store our integers inside the Java array, they will have references to individual integer instances right here. Okay, so these are all the objects that are going to be created. Right here we use only 2 of them, but if I kept adding like 2 more, this would be the picture right here, right? So these are other objects that we can add to this array, and I'm just trying my best to show them in my drawing right here. Okay, but this is how it looks like. So remember that, so this is Java array, primitive Java array. This is our array list, and these are individual objects, integer, instance of integer class, which encapsulate the integers 1, 2, 3, 4, 5, 6, and so forth, right? So these are actual values stored in computer memory. So this is how this array list looks like. But the limitation of array part of this structure in computer memory is such that its length is limited. So ArrayList in itself has ability to maintain a list of arrays. So the next time we keep inserting these values into our ArrayList, ArrayList will create another array of integers as necessary if we keep populating our objects with more values. And of course there will be a very similar structure right here, right? So we will be doing very similar structure, and so more objects are added as we move along if we keep just adding and adding and adding. Okay, so in itself, ArrayList, which is this object right here, is a list of arrays, primitive Java arrays in computer memory. That's why it's combined name like this. It's a list of arrays or array list. So that's the name of the object. Now we were clearly able to demonstrate that by swapping ArrayList with LinkedList had no impact on this code, because this code right here was written before I switched from ArrayList to LinkedList. So what is the difference between ArrayList and LinkedList? And here I could also use an integer. Now I'm using a string here. But LinkedList, internally what it does, it maintains a list of nodes like this. So individual elements are stored, okay, in the linked list. So these are all boxes that represent these strings. okay, right here. And ArrayList is just a sequence of list nodes which each have a reference to the next element, like this, okay, and reference to the previous reference, like this. And here, of course, the reference to the previous value is null. It does not exist. And here, a reference to the next element over here is also null, so it does not exist. So this is how linked list is organized internally. And these node objects, the nodes of list right here, contain, of course, the reference to the actual payload. Okay, so this is where the strings are stored. So the payload contained by the node points to an actual object that contains the value. So all of these will have these the actual objects, such as strings or integers, if this was a list of integers that would store the actual value. So this is the difference between the array list, which was this part of my drawing right here, and the linked list, which is a linked list of references to the next and the previous object, so that's a different organization in computer memory in terms of the linked list data structure. So typically classes such as linked list and Java library implement a doubly linked list so that each node inside the list points to the next one, to the next one, and to the next one. Okay, and then to the previous one, to the previous one, and to the previous one. And so that's how these lists are organized. And each node has a reference to an actual data object, such as the string, right? So the string is right here, and right here. So these are separate objects in computer memory, but the list stores references to them. Okay, so this part right here, up here in our drawing, represents the linked list. You can see that there is a significant difference between the linked list and array list. Now, for the sake of efficiency, I recommend that you always start with array list. If you find out that you have certain performance bottlenecks or certain things that you know very well about, that you should be using a linked list instead, then you should be switching to the linked list. I always recommend that for just generic sequence of elements of any type, of any kind, you just choose an array list. Use array list whenever possible. Its performance is very good because it's based on very basic idea of Java array, primitive Java array, and it's only linking together a set of Java array objects in memory, and so the performance of array list is always pretty good. Sometimes, however, some considerations may require you to switch to the linked list, but this should be your priority number one. For like 90% of cases, this is all you need for a dynamic array of your objects.